So one thing that a lot of kids hate about proofs is that it's not just okay to say that these two triangles are congruent. In proofs in geometry, they'll want you to explain why these are congruent, right? And so this lesson has to do with proving triangles congruent, and in particular, these three proofs, which is SAS, AAS, and HL. And what they are is side, angle, side, angle, side, and hypotenuse leg. They're pretty straightforward, and really the name itself tells you exactly how to handle it. And so the first example we'll do is the SAS, the side angle side, and I've already laid it out for you. This is what it looks like when you have two triangles that are congruent by side angle side. And what really matters is the order has to be perfect. Here we have side, angle, side, directly correlates to this side, angle, side. And you'll notice that the one tick mark matches the one tick mark, one curve to one curve, that's the angle designation, and then two tick marks to two tick marks. What is not true, so these, yes, these are congruent by side, angle, side. But what would not be true is if you had something like this. You had this side, this angle, and this side here. And then over here you had side, angle, and then a side over here. They have to be exactly in order and exactly matching for them to be congruent. So that's kind of explains side, angle, side. Now here's, as usual, with any of these, when I give you a straightforward example like this, you're thinking, wow, this is super easy. But there's always kind of like weird cases where you'll have to, kind of focus or use critical thinking to decide whether or not two triangles are congruent by SAS. And here's one of them. Here's a classic example. So here you're given two triangles that sort of look like maybe they're congruent, but again, I have to prove they're congruent. And in particular, we're trying to test to see if they're congruent by side, angle, side. And I see that the two sides part of it, I definitely have this side is congruent to this side. They're the same length. They're 10, whatever the units, centimeters, inches, whatever. And I know that these two are definitely congruent. So I gotta have this side and the side, but I'm missing the angle in between them. And if you look at the order, this would be side, angle, side. So really I'd want these two to be congruent, and they're not. I don't see any markings. There's no indication that these are congruent. This is what's slightly frustrating for kids about geometry and proofs, is that these actually totally are congruent. And you kind of have to have some background information. And if you remember, these angles have a specific name. Anytime you have an X like this, or what I like to call kind of a bow tie, the angles on the opposite sides of the bow tie or opposite sides of the X are always congruent by vertical angles theorem. So these are congruent, and that's kind of annoying, I know, because you had to sort of just know that. But now that I did know that vertical angles are congruent, don't I have side, angle, side, matching side, angle, side? So yes, these are definitely congruent by SAS. So that's the weird example for side, angle, side. Now for the second example, angle, angle, side, again, the name just gives it away. You want the angles in a row and the side last. And so this is a perfect picture here depicting that. You have angle, angle, side, angle, angle, side. So these are definitely congruent by angle, angle, side. And you'll notice that here this angle is designated by an arch and one tick mark. Arch, one tick mark. Down here is 2 and 2. That's how you know they match. And here you have 3 tick marks, 3 tick marks. Again, all that really matters is that they're identical, which indicates that they're congruent. So yes, these two triangles are congruent by angle, angle, side. And again, you could think of maybe sort of some weird examples. There's infinite scenarios that come up, but if you're critical about it and you're really focused, you can figure them out. So here's one that might be a little weird about angle, angle, side. Right, and this one's sort of similar to the last example. Right away, I see vertical angles. Whenever I see a picture like this in geometry, a bow tie or an X, even if it's not necessary, I automatically come in here and just say, listen, I already know that these are congruent. That's the first thing I'm just going to mark that in case I need that information. And we do in this case. Now you see we definitely have two triangles that are congruent by AAS. And what's weird is you'll say, no, actually, Ryan, I disagree. You'll say the order is side, angle, angle. This does not say side, angle, angle. First of all, clockwise, counterclockwise doesn't matter for these proofs. You could go this way. Angle, angle, side matches angle, angle, side. So these are congruent. So that's what's a little bit weird about these, is that it is not true that it would have to be angle, angle, side clockwise. As long as they're in a row, angle, angle, side, then these do work. So these two triangles would be congruent by angle, angle, side. And again, back to the vertical angle theorem, as long as we know these are congruent, usually it's helpful in a proof. In this last example, HL stands for hypotenuse leg. Right away out of the gates, the one thing you have to know about the HL proof is that it only works for right triangles. And remember, a triangle is not a right triangle unless they explicitly mark this as being 90 degrees here. This little box indicates 90 degrees. So yes, we have right triangles, and we have the hypotenuse. Remember, the hypotenuse is the longest side across from the 90. So we have the hypotenuses of each are congruent, and one leg. We don't need the last leg. And the reason this is even true is because you remember a squared plus b squared equals c squared, probably, where you can solve for the different sides given certain information. This is similar to SSS because if these two are congruent, these last two have to be by definition. So actually, this is kind of similar to just having all three sides congruent. But nonetheless, again, never mind like the derivation of why it works. You'll just know that if the hypotenuses are congruent and one leg is congruent and they're right triangles, automatically these two triangles are congruent by HL. And so here's one kind of weird one. This one's totally straightforward, but here's maybe a potentially weird one they'll throw at you for hypotenuse leg. Right, what if they give you a picture like this and they don't give you any markings, but they say this shape is a rectangle? That automatically, again, you're supposed to have a bunch of knowledge about rectangles going in that would make this so that you could figure it out. Again, you would remember that for rectangles, all of the sides are congruent, and more importantly, all of the angles are right angles. So couldn't I automatically say for these two triangles, this angle is right and this angle is right, again, because it's a rectangle? And the answer is yes. And if you look at the hypotenuse of the bottom guy, it's this. Isn't it true that the hypotenuse of the top guy is the same line? You can definitely say that they have that line congruent to one another because it's the same line. So you can literally mark this 3 mark for the bottom triangle would be congruent to this triple mark for the top triangle. That's kind of weird, counterintuitive, but when two triangles share a line, that counts towards your proof. And in this case, it's the H part of my proof, the hypotenuse. And then I know that rectangles, opposite sides are congruent. Don't I know that this side is congruent to that side? So here I have right triangles with a hypotenuse and a leg, right triangle, hypotenuse and a leg. So yes, these two triangles would be congruent by HL. Again, just because I have some background knowledge of rectangles. So those are the 3 proofs: side, angle, side, hypotenuse, leg. They're pretty easy, teachers are creative and they can mess with you and try to make it confusing, but overall that's how they work. Again, focus on order. Order matters, and if you keep an eye on that, these are definitely doable. So I think you guys will do well. Hopefully you enjoyed that video.